All right, we are going to work on literal equations. These are equations that have lots of letters in them. We're going to isolate the indicated variable in the equation, and it's going to work out great. It just takes a little bit of time. So, before we jump into equations with lots of letters, I just want to bridge that gap from simplifying expressions to solving equations. So you know where I'm coming from with the language that I'm using. Since I don't teach your class every day, I want to make sure we're on the same page throughout this presentation. Okay, to simplify an expression, and an expression is something that doesn't have an equal sign, to simplify an expression, you use order of operations. And I love order of operations. I think as kids we were taught, please excuse my dear Aunt Sally or my Aunt Sue, or maybe it was your Aunt Sophia, whoever your aunt that starts with the letter S's. And that just meant like PEMDAS, parentheses, exponents, multiply and divide, add and subtract. And the reason multiply and divide are together is because you multiply and divide from left to right. Whatever you get to, you do first. Add and subtract again from left to right. If I come to subtraction first, that's just fine. I do these from left to right. And that helps us simplify expressions. So we could use it to simplify this expression. 3 parentheses 2 take away 54 plus 4 to the third power take away 18. And to simplify this expression, which means we're just going to group things up as best we can, we are going to use order of operations. And the first thing we would have to deal with is parentheses. Ta-da! Which is here. 2 take away 54, which is negative 52. All right, exponents. If you have them, not all expressions have them, but this one happens to have them as a bonus. So our exponent, 4 to the third power. So that's 4 times 4 times 4, which is 64. So you just plug that baby right where you found it. Now we're going to multiply and divide from left to right. So 3 times negative 52, I don't have any other dividing or multiplying, so just 3 times negative 52 gives me the negative 156. And I still have my plus 64, take away 18. And lastly, according to order of operations, I add and subtract from left to right. Negative 156 plus 64, take away 18 gives me a negative 110. Ta-da! So order of operations helps us to simplify expressions. An equation has an equal sign, and we're solving equations because there's a variable. When I teach students how to solve an equation, I have found that just stating order of operations backwards tends to click. So they know what to get rid of first. So we're going to go backwards or in reverse. Before we go backwards, let's just talk about what that means. So we're going to use this equation in just a moment. We're going to solve for x. Negative 9x take away 15 equals 48. We're not up to a literal equation because there's only one letter here. Let me tell you, when you get to those literal equations, there are lots of letters. We're not there yet, but that's okay. So order of operations backwards means when we solve an equation, I'm first going to get rid of adding and subtracting. Then I'm going to get rid of multiplying or dividing. Exponents, and there's not a lot of exponents in the equations that you're using to solve. And lastly, I take care of parentheses. When I state get rid of an operation, that means you do the opposite. So in this case, I have take away 15, and the opposite of subtracting 15 is to add. So we're looking at opposites. So let's just go ahead and do this. So order of operations backwards says I have to start with adding or subtracting, and right there's take away 15. The opposite of subtracting 15 is to add 15 to both sides, and I mean both sides of the equal sign. So I add 15 over here, and negative 15 plus 15 is 0, and 48 plus 15 is going to give us 63. So I still have that negative 9x, because it's negative 9 times some number equals now 63. Okay, moving down my list, going backwards, technically backwards. Multiply or dividing. I have negative 9 times a number. Okay, what's the opposite of multiplying by negative 9? Divide. Divide by negative 9. So negative 9 divided by negative 9 gives me 1x, and 63 divided by negative 9, a positive divided by a negative is a negative. So now we were able to solve by using order of operations backwards. Okay, so now that our lingo is going to be on the same page, I want to make sure we had that down before we moved on. All right, here we go. A literal equation. It's really just an equation that has a lot of letters, or variables is basically what they are in it. And you've seen a lot of them lately, like A equals LW, D equals RT, P equals 2L plus 2W, V equals 2 pi r squared H. Do you remember where these are? Um, they're basically math formulas. Area of a rectangle, distance equals rate times time, perimeter of a rectangle, 2 lengths plus 2 widths, volume of a cylinder, 2 pi r squared h. Those are literal equations. That's pretty much what they are. Except what we're going to do today isn't substituting. Okay? What our goal is, we're going to rearrange them to isolate a desired variable. And what isolate means is, see how the capital A here is by itself on one side of the equal sign and all the other letters are on the other side? Right now the capital A is isolated, but the L and the W are not because they're in a group. They're not isolated. They have a group. They have a party going on. But poor capital A is all alone. Or same over here, capital P for perimeter is all alone. And look, everybody over here, 2 L's plus 2 W's. They're like, yeah. Well, we're going to ask you to isolate maybe the W and go, I'm sorry, W, you need a timeout. You need to be alone. So we have to get rid of everybody over here and move them over with the capital P. That's what it means to rearrange the formulas. But they have to mean the same thing when we're done. All right, I'll show you how to do it. Let's start with a basic one. Distance equals rate times time. Now, we're going to do order of operations backwards to solve it. And order of operations backwards says we're going to start with adding and subtracting, go to multiplying and dividing, any parentheses, any exponent. And pretty much this equation, there's no adding, there's no subtracting. I don't see any dividing, exponents, or parentheses. So basically I just have to undo multiplying because it's really D equals R times T. When a letter is next to another letter, it means to multiply. Okay, well, since r is being multiplied by t, you must do the opposite of multiplying, which is dividing. So let's divide both sides by t. So I'm going to divide the capital D by the t. I'm going to divide RT by t because I'm trying to get r alone. R needs to be alone. It needs some time by itself. And when I do t divided by t, they cancel out because t divided by t is 1. Just like pesos divided by pesos is there's 1, it's gone. And so I'm left with D divided by T equals R. R is now isolated, all alone. And that's your answer. You've reached your goal. Your goal was to solve for R. R is now alone. You did it. So D divided by T equals R is the final answer. Ta-da! 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 All right, let's step it up. Step it up. Let's do that perimeter problem. P equals 2L plus 2W, and yes, W needs to be alone. We're going to isolate you. So when you look at the equation, look at what's happening inside of it. We have adding going on and we have multiplying. So I don't have any subtracting, I don't have dividing, there's no exponents, there's no parentheses. So when I do order of operation backwards, I need to get rid of the adding and the multiplying. What do I do first? Well, I'm going backwards. I have to get rid of the adding first. So backward states we would get rid of adding first. So we need to subtract the entire 2L from both sides. So this is 2L, so it looks like this. I'm going to subtract P take away 2L and 2L take away 2L. Now there's no more 2L. And I am left with P take away 2L equals 2W. So I'm getting closer. The W is not alone yet. It's still hanging with the 2. It's like, no, don't let me go. But now we have 2 times W on the right side. How do you get rid of multiplying by 2? Well, you divide by 2. So we're going to divide this whole side by 2 and the other side of the equal sign by 2. All right. The 2 cancels out on the right side. See, 2 divided by 2 leaves me the W alone. And I am left with P take away 2L divided by 2 equals W. Now, I want to make sure you understand that you have to divide the entire left side here by 2. That's why this division bar is under the whole thing. I just can't go, hey, just divide this part by 2. And what helps me is a lot of times I'll just put that in parentheses, so that way it just reminds me I need to divide, put the whole big bar here and then a 2 underneath it. So that way I get W alone. And now W is all alone. And it's okay. Sometimes we need alone time. All right, let's do it again. Oh, Oh, there's a 1/3. I bet this problem is really special. 1/3 u, take away 8 equals y. Now this isn't one of our math formulas, but we can do it. We can solve for u because we're going to use order of operations backwards. So let's just analyze our equation. Is there any adding going on? No adding. I don't have any dividing right there. I got multiplying 1/3 times u. No exponents, no parentheses. So where do I start? I need to undo subtracting first. So, because we can't do multiplying because we're doing order of operations backwards. And the opposite of subtracting 8 is to add 8, and we do it to both sides of the equal sign. So I'm going to add 8 over here, and negative 8 plus 8 is 0, so that leaves me my 1/3 u. And on the other side of the equal sign I have y plus 8. They are not like terms, so it's just y plus 8. So now I have 1/3 u. So I need to undo multiplying. Well, what's opposite of multiplying? Divide. But let's think about that. When you divide by 1/3, that's a fraction. So when you divide with fractions, you are really multiplying by the reciprocal. The reciprocal of 1/3 is 3. So you multiply both sides of the equal sign by 3. So I'm going to multiply this side of the equal sign by 3, so that's 3 times 1/3 u. And this side of the equal sign, that's parentheses y plus 8, parentheses times 3. What's 3 times 1/3? It's 1. And I don't write the 1 next to the u, but 3 times 1/3 is 1, because you do 3 times 1 divided by 3, and that would be 3 divided by 3, which is 1. Now, I moved my 3 to the left side of the parentheses. Technically, it's just like proper form, and math is where you normally see it. And some of you are like, oh, wait, I could do the distributive property. I could give everybody a 3. You don't have to. Don't worry about it. That's our final answer. You did a great job. You got you alone, all alone. Okay, let's do it again. Looks like you've been extra naughty today. Oh my gosh, here's you right here. So order of operations backwards. I start looking at what do I have? I don't have subtracting. I don't have dividing. There's still no exponents, no parentheses. And exponents and parentheses in these type of equations are kind of rare. Yeah, they may come up, but usually you're going to have just the other stuff. Okay, so I have adding and multiplying. So order of operations backwards states I have to get rid of the adding first. So the opposite of adding 9 is to subtract 9 from both sides of the equal sign. So I have to subtract 9 from my w, and I'm going to subtract 9 from 9, and 9 take away 9 is 0. So I have w take away 9 equals 14ux. Now, my job is to get that u alone. Look at this, it's 14ux. What does it mean to have 14 next to a u next to another letter? It means to multiply. The u is in the middle of the 14 and the x. This means 14 times u times x. They're all being multiplied. To undo multiplying by 14 and x, you can divide both sides by 14x, and you can do it at the same time. So I'm just going to divide this whole side by 14 and the x, and I have to divide the whole side of that equal sign, the whole side, by 14x. The whole side. So I'm going to put some parentheses around there. But 14 divided by 14 is 1, so that's out. X divided by x, that's out. Look what I'm alone with. I'm all alone. Letter U, you're alone. Okay, and so now here I have in parentheses, so I don't forget that I have to divide this whole side by 14x. And now I'm done. Okay. I hope I don't say okay too much in the video. That would really be annoying. If I do, I'm sure you'll email me and go, really? Could you knock it off? We did it. We have you alone. Isolated. How's it going? Are you doing okay? I'm sure you're telling me, more, give me more. Let's do it. Now we're going to solve for W. Again, order of operations backwards. Let's see what we have. We have y equals 2x plus w, and that whole thing is being divided by v. Well, just a note here, since the entire right side is being divided by v, it is like 2x plus w is in parentheses. You cannot touch the 2x plus w until you move the v. So I'm just going to put some parentheses around there, because I know order of operation tells me if I'm going backwards, parentheses is last. Do not touch the 2. Don't touch the x, don't touch the plus w. I need to solve for w, but order of operations says parentheses are last. And anytime you're dividing the whole side by something, and you need to undo it, you got to undo it first. So let's talk about it. What's the opposite of dividing this whole entire side by v? It's to multiply both sides by v. So I'm going to multiply this side of the equation by v, so I have v times y. And I multiply this whole entire side by v. And notice my v's will cancel out because one's in the numerator, one's in the denominator. So I'm just left with that 2x plus w. And I'm just going to drop those parentheses now. It's okay because I'm not being divided this whole side by something. All right, my goal is to solve for w. Here's my w. All right, so I have 2x plus w. I know it's 2 times x, but that whole 2 times x is being added to w. Since I'm trying to get w alone, I just need to do what with this entire 2x? Don't tell me divide. Only the 2 is being multiplied by x, but that quantity is being added. So the opposite of adding an entire 2x is you're going to subtract the 2x. So I'm going to subtract vy, take away 2x. 2x take away 2x just leaves me that positive w, and it's vy take away 2x equals w, and that's going to be our final answer because w is alone. These are tough. They really do take a lot of time to figure out, mostly because you can't substitute in a number and go, okay, I got my answer right. It's fabulous. Yeah, that is the tough part. And I'm sorry. They just really do take a lot of practice. So we'll do another one. That's why we're having so much fun. All right, we're going to solve for w again, and let's see where w is at. W, and what does that bar mean? Divide. W divided by 3, and then I'm going to add x equals y, but I'm going to do order of operations backwards. So am I going to get rid of dividing first or adding first? All right. So since we're going backwards, I have to get rid of adding first. And the opposite of adding an x is to subtract the x from both sides of the equal sign. So I'm going to subtract an x from this side of the equal sign and over here. So w divided by 3 equals y take away x. Well, this isn't too bad. I know what the opposite of dividing by 3 is. That's right. It's multiply by 3. So I'm going to multiply the entire side over here by 3 and this entire side. Remember, you have to do the entire side. So notice what I did. The entire side. Not just put a 3 on the end, the entire side. That's why the parentheses came in. And look at this. My 3's are going to cancel out because 3 divided by 3 is 1, and I'm left with 1w. And I'm left with this quantity, y take away x, in parentheses times 3. And again, proper math form would tell us to put the 3 right over here, and that's going to be our final answer. Wow. See? That one kind of made sense. Wasn't that nice? All right. Well, I'm glad you stuck with it. It does just take time. It's using those algebra skills. Cognitively using the algebra skills, you're really thinking about how to use them in order to isolate a variable. So keep up the great work, and I will talk with you again another time.